Okay. Well, thank you everyone so much for joining today. Another Balerion Space Ventures podcast. It's May 11th, and today we're joined by Karthik Gollapudi. Am I saying that correctly?
Perfect.
The founder of Sift. Uh, Sift is the company that's, as it says on their LinkedIn page, transforming how modern machines are built and operated. Karthik, so happy you're able to join us today.
Awesome. Thanks for having me.
So to jump into things, maybe we can just start with a high level overview of what you guys are building at Sift.
Yeah, of course. I'll give you a little bit more detail than was on that LinkedIn description.
Sure.
What we do is a little bit of background. So I started my career at SpaceX, spent about 4.5 years there. I was on the flight software team for the Dragon program. So that's a capsule that takes astronauts and cargo to space. And what I saw about what we were building over there versus what I started to see in the rest of the industry over my time there was that a lot of the tooling and the infrastructure that people use to build modern machines, whether it's planes like the Boeing 737 MAX or vehicles like Starliner, um, they were quite outdated and they're very different than the way we operated over at SpaceX. And what I mean by that is that at SpaceX, we built things where the way we built software and the way we built hardware was actually very similar. We basically built the hardware as though it was a software product. Whereas I noticed that a lot of the rest of the industry was still building hardware the way that we did since the Apollo era. And what I mean by that is it was very manual. You go build something, you go test it, you say it's flight heritage, and then you call it good to go. Problem with that is that you're there's a lot of risks that are in there that are not captured, that are only captured through subsequent flights, tests, etc. But then the other issue is there's this kind of this less tangible risk, which is attrition. And as people start to leave the company, you start to lose the knowledge about how something works inside out. And specifically the incident that I first started paying attention to the problem of how hardware is built is the Soyuz capsule. If you remember back when I think it was like 2022 or something, 21, 22, around that time, there was one of the Soyuz capsules. It got hit by a little micrometeorite, and it stranded the Russian astronauts in space, and they couldn't come back to Earth because they were um, like nobody can really figure out how do we maybe reroute different fuel tanks, how do we change the ConOps such that we can bring this vehicle back to Earth, and um, and that's when I started realizing that it's like, hey, the people who built this were working there in like the 70s and 80s, and they're no longer there, and that's why they're not as dynamic. And at SpaceX, whenever things happen, we can be a lot more dynamic to change. Even Apollo 13, right? It's like there, you saw the movie where people were able to figure out how they can bring this thing, even though it's not like the standard nominal procedure, how do you bring it back to Earth? So pretty much that's when I started realizing that the way that we're building hardware today feels kind of dated and broken and stuck in the past. And that's when I started paying a lot more attention to how we do it at SpaceX. And I realized that a lot of it had to do with a lot of the tooling that we had that enabled us to build hardware like software. And that's actually what inspired us to build Sift. So we build basically a suite of different tools. The category is called hardware observability. And it's like a data infrastructure product along with some observability tooling on top of it of how do you build and test complex machines.
Got it. Okay. So these complex machines, your customers, how are they using this day to day? What kind of challenges are they able to overcome with Sift on their side?
Yeah, of course. So let me maybe describe like where is Sift used. It's um, it's a system that takes all that sensor data off of the hardware, and then it gives engineers visibility into what's happening in the hardware. So you need to use that when the vehicle is in, let's say it's a satellite and you're in space. But even before you get to space, you're going to be testing that. You're going to be testing on a test stand. And even before that, you're testing in a simulator. So how is it used? It's primarily used for when somebody is testing a piece of hardware and they run it through some sort of sequence or some sort of it's doing something, and then you need to see what's happening. And with Sift, the power of it is that um, it can take data from all sorts of different data sources. So audio, video, logs, time series data, everything and unify in one single source of truth. as opposed to people SSHing into some machine to get logs, going and finding someone who has video, figuring out what database has the time series data. What we do is we get all that sensor data in one place so you can see what's happening. And then we have an automated analysis system that lets you put rules to monitor what's happening. And the reason why you want to automate that analysis is because these machines get pretty complex to the point that some of the vehicles we're working on might have like a million plus different sensors on there. So you can't, as a human, go stare at some dashboard and hope to figure out what's happening. You need to have all the uh, monitoring of that to be automated, and then you only pay attention when something goes wrong.
Yeah, and with manufacturing just being such a bottleneck in the hardware industry, a tool like this seems like a no-brainer.
Mhm.
Has something like this existed before? And whatever did exist before, when Sift came along, what set you guys apart to be so much better of a solution?
Yeah, honestly, I think it's one of those things where one is like there's like the theory and like what you should be doing, and then two is kind of the practice and like the actual tools to execute on that idea. So this idea of how do you build hardware like software, this concept was, I think it's like a bit of a concept that like SpaceX, Tesla really brought and made more prominent. So I think one thing is the workflow and that idea. But then the closest, like, I guess the most similar tooling to that would have been stuff that people was like, we're mostly building in-house. It's not like there's some company you can go to try to go get something that's like even doing some of these functions. Let's say you even like jerry rig some open source tools. You still it's like mostly just jerry-rigging tools that are developed for software and trying to make them work for hardware. And the challenge with it is that software data looks very different than hardware data. And what I mean by that is, for example, you're talking about millions of sensors on some of these vehicles. You're talking about the schema of that database changing with every software release. Like people put in new sensors and like mux two sensors together. That changes your database schema. So like who's going to be doing all those migrations? And then the other challenge with it is what about all the weird complexities of operating like in space? I mean, you guys are a space venture firm. It's like a lot of these companies that are operating in space have to deal with things like gravitational time dilation. So what that means is that actually, Aidan, did you watch the movie Interstellar?
I have.
Okay, awesome. So do you remember in that movie when they went to that planet with those really big waves and like
Right.
30 minutes happened? Basically 30 minutes progressed and the guy aged like 30 years on the ship.
Correct. Yeah.
So that concept, gravitational time dilation, means that time moves at different speeds based on the amount of gravity. So when you have like really high gravity, their time is moving at a different speed than someone in the ship. And for us, we have to deal with that effect. That affects like somebody has a satellite, somebody's going around the moon. They have different timestamps. So for one of the vehicles that we work with that goes to the moon, they have I think something like six different timestamps for every single data point because there's a timestamp on Earth, there's a timestamp in orbit, there's a timestamp of each of like the communication relay satellites, there's a timestamp around the moon. So it's kind of wild. But um, those are all like these weird little nuances and things that you won't necessarily solve with something open source off the shelf um, that was developed for like a mobile app.
Yeah. It definitely gets a lot more confusing. And like you said, that time issue, that's
Hmm.
one of many, many other, factors you can throw at this problem.
Hmm.
So yeah, I'm thinking about this, and this company's moved very fast. I've seen a lot of attention gravitating towards Sift. And you started this company with coming out of SpaceX with another I believe he's a founder, Austin. He's from SpaceX as well.
Yep. Yep.
So yeah, coming out of SpaceX, like what did you bring from the SpaceX culture and like, what did you leave behind?
What do you mean by leave behind? Oh, is it things that we didn't want to bring?
Things SpaceX you can get burnt out sometimes. Some people have said who've worked there in the past, or you know, maybe SpaceX has other goals of how they run their operations that didn't really apply as much to SIF.
Mhm. Yeah, it's interesting, right? You hear these things, and I don't know if I necessarily saw that manifest too often. Like this whole burnout thing, I think is yes, I would say that the company runs hot, But if you look at it, I mean, just look at the average tenure at SpaceX. It's way longer than industry average. Like people in your average tech company are there for like what, 2, 3 years, and they bounce between like Google, Facebook, etc. Like most of the people I know at SpaceX have been there like they say for 5, 7, 10 plus years, and it's I'd say it runs hot, but it's really there's no other place in the world to do those things. And now there are more of those companies, like K2 Space, Impulse coming up, but it is one of those things where I guess like kind of just dispelling some of the myths. Like I think it's very mission driven. That's one of the things we wanted to bring. The mission part, the um, first principles thinking, I'd say is one of the biggest things. Really challenging why you do something. And it's been really easy to apply that from engineering because we've seen that, but actually bringing that concept to like the go-to-market side of things. Like for example, I think just given the way the go-to-market is changing a lot right now with a lot of this more AI tooling, but also AI saturating traditional channels. I think there's a lot of new first principles thinkings about how do you build a go-to-market org in like a post-AI era. So I think that's some of the stuff we wanted to bring. First principles thinking, mission. Um, but some of the things we didn't bring, I would say, is we tend to actually hire a little bit differently. So at SpaceX, it was a lot of hiring like interns and then giving those interns return offers or hiring new grads. Um, and I think that's like the single best place to start your career. But what we did at Sift was a little bit more of, I'd say like that's basically a little bit more of like a brute force culture. Like you're young, you're trying a lot of different things out. Some work, not some don't. Whereas I'd say at Sift, it's a little bit more of like hiring a bit more senior, a bit more of like the work smarter rather than harder type of thing. Um, just because I think people have a little bit more experience with some of these things. And for us, I think it was mostly driven by cost, where it's like a matter of do you hire like one junior engineer or do you pay like 1.5x for 3x output type of a thing? Um, and also just when you're smaller, I don't think we have as much, doesn't have as much infrastructure around. Like SpaceX had a lot of infrastructure around that you can try a lot of things without breaking things. At Sift, it's a lot more. I think it's like there aren't as many guardrails, right? So we have to hire a bit more senior so you don't take down a production system too easily. Whereas at SpaceX, there's like a few more checks and balances in place.
Uh, and I'm thinking about this, the product that you sell, it's very advanced, and you're approaching potential customers with, a solution to, a very fragile balancing act they're doing with their manufacturing process. It might be kind of hard to win them over. So I'm curious, just what's been harder to do, build this product or sell into this industry?
Hmm. Well, I think we're biased because we are engineers.
Sure.
So the building part is a little bit more in our wheelhouse. Um, I think what is changing though is yeah, I think the challenge is also with the selling. The selling part isn't necessarily giving people confidence that that we can serve mission critical use cases. I think the selling part is more about evangelizing the problem space. So I think a lot of people they still operate on like a system of like this has flight heritage. This is the way things have been done. Whereas what I see is right now, it's kind of like this shift in software engineering from the 90s to 2000s. We went from waterfall to agile. You have a similar shift in hardware engineering right now, where this is like movement towards how do you build hardware more like software. And that's a lot of what we we do a combination of evangelizing the problem, but then also providing people the solution to that problem. So I think it's more about the evangelization is the harder part than necessarily the selling part of it.
Yeah. And going off that, thinking, you know, how you're hiring for this company, you're looking at people who need to really understand software and be good at software, but you're building and helping out with rocket satellites, autonomous vehicles all at once. So are you looking for that pure software engineer, or are you looking for people who've had hardware experience and really have had hands-on experience with these problems, seeing them and then knowing how to help create that solution through a software?
Yeah, so I mean, this comes back to kind of taking a more first principles approach to different parts of the company. So rather than just hiring everyone who comes from like SpaceX, which we have a lot of actually. I think we have something like 20 ex-SpaceXers here. Instead of just concentrating on one pool of people who have done this, we actually have different like for infrastructure. We build it. I think we're the only company that like really build. We're like the only hardware purpose-built database. So purpose-built for hardware sensor data. And because of that, what we want to do is actually get the best people, infrastructure engineers. So a lot of those folks might have actually worked at like interesting at Hulu, um, Netflix, Google, stuff like that. Whereas for the product side, you want people who have actually some of our engineers that are working more on like the front end and product side of things haven't even been software engineers before. They're like electrical engineers, propulsion engineers. So it's like slightly different skill sets depending on what the problem space is.
And when you're signing on a new customer and they have a unique problem, you know, lots of sensory input on your end, what does that onboarding process look like? Do you have someone who goes out there, spends a week with them, learns the problems that they're dealing with, and you have a specific design just for them? Or is there more of a universal tool that everyone can kind of use?
Yeah, so what we want this to do is feel as simple as any other like open source software product. So you actually could onboard yourself, get yourself up and running, and it's relatively straightforward. That being said, we do also, just because some of our customers do need a little bit more white glove service or they have pretty layered security setups for complex like let's say it's like a defense customer or someone that has it's like a defense prime that has lots of like on-prem requirements. We do offer like a more white glove type of service as well.
And when you're looking at all these new problems, maybe it's a white glove problem or maybe it's a very hands-on problem. There's the whole data overload problem. And you can just get overwhelmed with too much data. How bad is that? And to you guys, when you're looking at a company and they just hand you, a flash drive with so many spreadsheets, data points, things like that. Do you have a way to really, sift out that data, put it into silos, really break it down to help be perfect for Sift usage?
Yeah, honestly, a lot of our customers have a better understanding of this already. We're
Okay,
just giving them an easier way to do it. So it's it's kind of like they have a bunch of pages in a book, but they're like not bound in a book, it's just giving us a stack of papers. And then we put it into that book and give them a table of contents. And they kind of know what's there and what they need to go look at and where to go. We're just making it much easier to go access that.
got it. Is there a use case scenario you can share with us so we can get like a picture in our minds of a company, how it's operated, then Sift comes along and it operates much more efficiently? Maybe something you can share that isn't too technical and it's very easy to understand from a high level.
Yeah, yeah. So, actually, I think if you just kind of look at the way SpaceX uses this is
Okay.
probably the easiest way. So, you've probably seen that when SpaceX launches a Starship and if it does blow up, they pretty much figure out the issue. They like root cause the issue really quickly. They make the changes and then they validate it and it's good to fly again within like 2 weeks. If you think about it, that's kind of like unheard of in especially in the hardware industry. It's usually like a 6 month process. They do some like deep investigation. This like long back and forth. They go talk to all the different suppliers. They trace the suppliers and they go change the parts. It's like 6 to 12 months of downtime usually. So what we did is like that delta. That's because of what Sift does. So in this example I gave you was like the SpaceX equivalent of it, but pretty much the idea is let's say you have an anomaly on the vehicle. And then with all the instrumentation that you would like all that sensor data, since it's flowing into Sift, there's all this instrumentation, so you can quickly root cause what went wrong and find the specific issue. You can find the subsystem. You can see all the data from all the related subsystems all in one place. You're not like fishing and digging in different people, doing different departments. Um, like literally, some of these customers we talk to, they literally have to like go fly out and like go find this test stand that has like a server, and then take that flash drive and then upload it to the internet, which is wild. So for us, it's kind of like all the data is in one place. You can quickly see it, and then all the different subsystem experts across the company, whether you're a prop person, whether you're a GNC person, whatever, you can go see all the data in the same place. You can see all the different flags that went off. So you quickly root cause the issue within hours. And then what you have to then do is um, you can make these changes in simulation. And then what you do is you run that simulation through the same scenario. And Sift would have been able to validate it as well, the same using the exact same checks that are on the vehicle. We're running the same checks against your simulation, which is another big issue, right? So I think it was Intuitive Machines. They had their crash landing on the moon. Not the most recent, but the mission before that.
Two of them.
Um, well, I mean, both of them did, but the first one, I think it was because they had that LiDAR turned off. And if you look at the press release, they basically said that the way they tested this on the ground was a different test suite than for flight. So they were able to test that on the ground test that the LiDAR would be turned on, but the flight test suite was different, which is kind of crazy if you think about that. Like imagine if the software we deployed to the world, we like we tested it all and it was good to go. And we deployed it to the world with a whole different test suite. Of course, you're going to have issues and not catch things. So the idea with Sift is like we can root cause the issue, validate it really quickly in simulation using the same test suite that you use in production. And then all those tests as well, that rolls up into a report. Sift would generate that report and you can just give that to the FAA and say, this is good to go. Was that too long
Yeah.
and technical or is that
No, no,
making
that
sense?
makes sense completely.
Okay.
Yeah, even simple tools, if you're just able to see all the data in one place, nice and
Yep.
visualized, it helps so much. And a lot of software companies have made a lot of money just making pie charts look pretty, I guess you could
Yeah.
say. Uh, so as I'm thinking about this, there's a lot of things that have happened in the past 3 to 5 years with AI, and it keeps on growing and getting more advanced. How's Sift been able to shift along with this transition? And would there be a point where, say, Claude is now a competitor because it can, show the data and, sensory points so easily and efficient that maybe they don't need to get a software to run every task of, managing the sensor data?
Yeah, definitely on the product and the front end side in terms of navigating the data. I would say a lot of these more AI, like these different AI tools are the way to go. But the challenge that we have for our customers and where we spend most of our time is on the infra side. So how do you even get all the data in the same place to start with? So how do you get the data normalized? Like the timestamps I was telling you about. It's how do you even know, how would Claude necessarily know that this log was run at this timestamp, whereas this video was at that timestamp? And then like how do you normalize all this data? And then also how do you expose this like basically what we do is we would create that table of contents that Claude can then go navigate in the book. But the thing is that if you just gave the raw pages to Claude, it wouldn't necessarily know what to navigate because it would be um, all this data in disparate places with like different timestamps, different formats. Um, and on top of that, you might not even have the data in the first place. So a lot of what we work with our customers is also just getting the data and getting access to the data because it lives in all these different silos.
Yeah. Can this extend beyond into other domains? What I mean by that is like, could this be used for space domain awareness or, you know, navigation for submarines underwater, things like that? It seems like the sensor data and having it all there is quite useful. So beyond just looking at the internal system, could it go into something like one of those industries?
Yeah, I mean, I'd say only about half our customer base is from aerospace. The rest is split across, as you're saying, like maritime, energy, defense, um, robotics, automotive. So yeah, definitely applicable broadly. Um, unless you're asking about like the use cases. I think you're talking
Uh,
about industry, right?
yeah, I'm curious about like the use cases if, they could use the sensory data from cameras that are, navigating the situation around them, whether it's a satellite in space looking for asteroids or other satellites to avoid, running into each other, to, you know, maybe sensing how, the ground level works at a manufacturing plant and seeing, the workers and all the factories work just from, a webcam that's on a high pole looking at
Yeah,
everything.
yeah, definitely. So that's what I think what you're describing are a lot of those different use cases. So what we do is we build that infrastructure, get all the data accessible to the customer, and you can build all sorts of different use cases. There's some of the use cases that we help the customer with in terms of this like building hardware like software types of workflows. But we actually do have customers who like what is it? One of our satellite customers that does communications. They actually have like a full suite of customer dashboards that they show for their end customers that are pulling all the data from Sift. Or we have another person who they build like engines, and what they do is they actually have their full factory and they have a bunch of like factory analytics that are run and monitored through Sift. So definitely hear you, and we do that with different we provide the data, and then the customers can bring their own use cases and build on top of Sift.
Yeah. And from the time you were founded up until now, it seems like you've had incredible traction. You mentioned SpaceX using this, and you have
Well,
other.
SpaceX isn't our customer. I was just saying that we were
Okay,
inspired by what we learned at SpaceX.
I see.
Yeah.
But some of your customers on your website are like Impulse Space and
Hmm.
K2, other very large companies. I'm curious how you were able to get in the door of these neoprimes, maybe you call them, large aerospace companies, and have a solution that's like so advanced and helpful that it kind of surprises me that no one came along and did this before you, or they didn't build it internally, or maybe they did, it just wasn't as good.
Yeah, I mean that's what I was trying to say. That most people were there were actually quite a few people who built some of these things internally, especially like the large defense primes. But if you think about it, their core competency is hardware, not software. So they
Sure.
don't tend to have as much investment into this. So also, if you think about the way the hardware programs are financed, it's kind of like, hey, we're gonna go build this thing, we're gonna budget this money for it, and then it's built. Whereas if you think about software, it's actually more of an iterative development and you continue to improve software and it's an ongoing thing, which is why like the concept of like SaaS is actually a lot more supportive of software development models, like the engineering model as well, not just the like the business model. So we we're able to continue investing on this. And also, I mean, what we're 80 to 90 people now. So when you have that many people that are so focused on this problem, it's much more than like what a company is going to be able to invest internally.
Yeah. And as I'm just thinking about the scale up and the growth of your company, you've had, you know, a lot of tier one, very good investors getting into Sift. Do they fully understand this problem when they speak with you? Or are they kind of inspired by, your presentation, your pitch, and you explaining how important this is? Or maybe they're just inspired by some of your customers. I'm curious what some of the best things have been that have helped your trajectory grow so fast over the past few years.
I think it's a little bit of all of it. So it's a matter of like you're putting this into an investor perspective. It's kind of you're looking at what is the problem, like how expensive is the problem, or like how much are people willing to pay for this to solve this problem, and then how many people are there, like the market size. So when you look at it, there's two things that are in our favor right now, where there's um, in terms of like the ACVs, a lot of our customers do pay us. I think most of our customers are six figures, seven-figure customers. And that's because it's a pretty painful problem. It affects actually a lot, almost everyone at the company. So the cost is high or the pain is high. And then in terms of the market, it's a decent sized market today, but it's actually a growing market. Very much like when you look at investing in this, and I mean, you guys are named Balerion on space ventures, right? So space alone is a massive sector and a
Yeah.
growing sector, right? So there's that along with just a renaissance in hardware as people are realizing that you can build large companies in the hardware domain, whether it's SpaceX or other Anduril and these other companies. So I think it's a combination of market and the amount of pain that people are willing to pay for.
Yeah. And for the timing aspect of it too, it seems now is such a great time for a company like yours, given the you know, the scale up of hardware companies, hardware tech, space and defense, companies like that. In your opinion, what is one of the biggest drivers that's creating this push of momentum that's helping Sift and all these other companies wanting to move so fast?
I mean, probably the $1.5 trillion defense budget, right? So all that is trickling down into defense primes, into um, especially because I think people are realizing that space is the ultimate high ground. Well, I guess the moon is probably the ultimate high ground, but space is probably the most accessible ultimate high ground for now. And people are seeing a lot of the money flowing from that defense bill into space. So, but also just hardware more broadly, right? Like a lot of the expensive hardware is built by these defense primes and by for governments. So, I think that's probably the biggest single driver that's saying there's money flowing into the space. And then the other big driver is going to be um, SpaceX IPO showing that you can have liquidity on these companies. Um, and then Um, yeah, I think both of those are probably the two biggest factors. Oh,
And
sorry. There's also now people are starting to see like a linkage between AI and space, right?
yeah,
Was a Cowboy Space, whatever. It was the Aetherflux pivot that was announced today. There's like everyone's doing orbital data centers and uh, things to support that supply chain because they're realizing that there's actually a pretty viable path to scale AI compute.
yeah, and with this hype, you get a lot of people like interested who are outside of the the spectrum of this industry, like investors trying to jump in. In your opinion, like what are some things that investors, VCs maybe get wrong about these hard tech infrastructure companies that they really should understand before they jump feet first?
Yeah. Well, I wouldn't necessarily say get wrong, but where I would say is like to maximize your alpha or like to maximize your yield. I think where because you can invest in a lot of companies that will be like tier two or so. But it's if you want like the top tier one companies, I think it's really a challenge that spans both go to market and engineering. Um, it's kind of weird. It's almost like I was saying negative stuff about heritage most of this conversation, like flight heritage. But actually, I think there is a concept of like talent heritage that's a little bit different though than necessarily saying that, hey, I've just like worked in the space industry for 40, 50 years. But have you worked in the new space industry and the people that are doing things differently? I think that's actually it's like a new space heritage in a way, which is I guess kind of a it's a bit of a oxymoron, but the almost like this new space heritage, I think is really important to know how do you build machines for the next era. I think that's where a lot of investors might be missing, as opposed to saying, hey, this person has um, like they worked for 50 years at in the space industry. I don't know if that's actually the thing that I would invest in as much as they spent 5, 10 years at SpaceX and you look at the density of talent that's at specific company. So I mean, you even said this yourself earlier, like K2, Impulse, like part of the reason those companies are killing it is because they have the best engineering talent. Um, Plus, they also have figured out the go-to-market aspects. So I think it's if you want to maximize your alpha, I think that's the challenge. That's the area that investors really need to pay attention to. It's not just the go-to-market or just can they sell into defense contracts because I think the challenge with that is you have a single customer. Will this company be dynamic enough that if that customer, let's say the next administration decides to reel that $1.5 trillion defense budget back, will they still have anything there if they aren't a dynamic company, they don't have that deep of a technical moat, and the few Space Force contracts they had dry up. So I think that's what I would look into. Um, yeah. And then also like a longer term path for liquidity. So I think that's also another thing that's been changing in the market. So you see Anduril, for example, buying up a lot of these startups that may have figured out some of the tech, but don't have as much of the go-to-market aspect figured out. So I think that's actually that's another like hype or tailwind for this sector that there's more alternatives for liquidity because a lot of the primes didn't do as many of these acquisitions um, as maybe more Silicon Valley-esque companies go into the space.
Yeah, absolutely. And with, these fast companies, you have, the older prime companies in aerospace and defense, they're trying to catch up and become fast too. And you said it, a lot of this push is coming from the trickle down budget, 1.5 trillion that the government is spending in this area. So is the government, are they coming and talking to you and trying to get a full understanding of this? Is there things that they need your help with, maybe for their own systems?
Yeah, definitely. I think it's um, I can't disclose too much, but
Sure.
yeah, we have some projects we're working on direct with government, and then most of it though is through people who sell to the government, so government customers, so like defense primes, for example.
And how different is it selling into defense versus commercial space, or the commercial space startup that just moves really fast?
Well, I think the use cases are actually very different. So a lot of it is what is the government sector, what is a government group trying to do? But typically, government's not trying to go build a satellite or build a rocket themselves. They might be operating it, they might be doing some compliance testing, they may be doing something of that nature, but they aren't typically building it themselves. So the use cases are different in that sense.
Yeah. And as we're growing really fast in this industry, we're seeing a lot of these startups not really be startups anymore. They're buying, million square foot facilities to really scale up production and manufacturing. And they're past the point of proof of concept and they're just
Mhm.
trying to grow and build really fast. Is that a tailwind that really helps out Sift that you provide a lot of help for? So as they grow in other sectors like manufacturing and factory lines, they can really benefit from having Sift on their side.
Yeah, definitely. I
And
mean, I think it's the same tailwinds in terms of just general sector growth, causing customer growth, causing them to sift growth as well.
yeah, and as this chain continues to grow and move really fast, I'm curious of your opinion of the major changes we're going to see, 2, 3, 5 years from now that maybe we're starting to see now, but it hasn't really kicked in. But what we could expect to be much different or somewhat different in the near term future.
Yeah, it's kind of interesting when I was at SpaceX back in I think like 2019 or so, we had these like Starlink was like a side project. There was one or two Tintin satellites. You didn't hear much about it. It seemed kind of like this like small like si side quest that SpaceX was doing. And like the whole idea of like space-based internet, it was like, okay, maybe we'll do this for a few um like government customers or something like that. But that wasn't really like a thing that you expected to be so prolific that like you go meet someone off the street and they know what Starlink is, or every time you fly on a plane, you're using Starlink. That wasn't like that scale isn't something that was necessarily as intuitive back then. So if you go fast forward now, instead of 5 years in the past, you go 5 years in the future. I think a lot of the stuff that we talk about with orbital data centers, direct to cell on Starlink, um, the Starship flying regularly, I think that's actually gonna be a lot more normalized. Like people think, oh, 10,000 10,000 Starship flights a day sounds ridiculous, but what is it? We currently have like 1.5 million plane flights a day. So I don't know if it's that crazy to think that we're gonna have like 1% in 1% worth of rocket flights a day, or less than 1%. So I think a lot of these things are that sound a little science fiction today are going to feel a lot more normal in 5 years.
And are people who are using Sift, are they able to dramatically outpace everyone else in this industry? And maybe there's a two-tier system that's just going to continue this new space and old space, as we talked about.
I mean, you said it, not me. So just look at our customers
Yep.
and look at who's not our customers. So I think that's a clear enough signal.
Yeah. And as you grow in scale, what does that look like in terms of team build out versus hardware and new technical build out? As new hardware solutions start existing in this industry, are Sift going to have new applications to, you know, be able to keep up with that? Or is your software already able to cover just about everything and maybe you need to scale up the team or, iterate on softwares to make it faster, more simple?
Ooh, well, definitely be scaling up the team. We've grown from about 30 to 80 or 90 this year so far. Probably going to keep growing that. Um, But in terms of product, I can't share too much, but there's a lot of new product stuff coming out that's more supportive of where the style of software, like overall, when I said we build hardware like software, the way the software is being built is changing, and we're going to be bringing a lot of that to the way the hardware is built as well.
Yeah. And, why can't like a big data company like Palantir or Datadog just jump into this and, you know, put a lot of money in, become a competitor to you? Is there a really big moat that they would face if they were tried to jump in and start doing what you guys are doing?
I think in theory, yeah, they could. I mean, with enough money, um, and enough money and time, they definitely could. I think the challenges that they're going to have to do with domain expertise around what are the important problems to solve. It's not just about building a scalable database. It's about doing things like building a two-fault tolerant database. How do you support multimodal, like physical world data? How do you support these use cases like gravitational time dilation into your database? So I think a lot of the moat aspects for us are going to be on the way we built our infrastructure, purpose built around hardware development and working with hardware sensor data for very mission critical use cases. Um, so with enough time and money, yes, but I think we have a pretty solid lead that it would take a few years for them to catch up.
Yeah. And even if they're catching up, they're going to have to build ground up most likely. And considering the pace that you're on, they're not going to be competing. They're going to look at you right now and think of what they can compete against when in reality, when they're done, Sift will probably have five brand new features and they have to think about what you're going to be doing 2 years from now, 5 years from now.
Exactly, yeah. And I think a lot of it is if you're in the shoes of like a Palantir or Databricks or something like that, it's if you want to go in the sector, I think a lot of it is you want to go find the people with the domain expertise, product expertise in this as well. So a lot of times it's easier to just go acquire a leader in the space rather than um, doing this, trying to go build this yourself. Whereas I think in terms of acquisition, if you're trying to go build something in the space, I think it would be yeah, because a lot of it, it's like that. I think that's one of the things I learned when we have this company. It's like people really matter a lot more than people realize. And like the specific expertise or relationships or understanding and experience really does have a significant effect on the end result.
Yeah, and thinking about just the software industry as a whole, with new AI that's coming out and making a lot of things very easy for people to do, and companies like Sift that are able to enable hardware a lot. Do you think for the most part, the party's over for software? Are we running like out of time of just seeing those 40x exits now that people can build internally all the simple tools that may have required 50, entry level coders? And what is software going to look like a few years from now after we saw that big wave from the 2010s? I think that wave may have passed.
Potentially. I guess like maybe it's worth thinking about like what is software. And there's software that you use to go do something else. Like let's say like Hims, right? Let's say you're buying medication on Hims. Like I don't really know if that's going to be all that effective because you're just using software as like a tool or a medium in order to go get your medication. So in that sense, I don't think it's really affected. Um, and if anything, it just helps Hims margins. But then there's software where the end product is software itself. Um, so like let's say a CRM
Yeah.
or like a software like a CRM or analytics tools, things like that. I think that there are certain parts that people need, and then there's other parts that are people will not need because so like ERP, CRMs, manufacturing execution systems, all that type of stuff. I actually think people are going to build those things in-house themselves because they want more what does it say? What was it? They want to make this stuff more customized for their workflows, right? Whereas there's other things that you don't want to do yourself, like for example, the underlying database and the data infrastructure. Like those are things you just don't want to screw up, and they end up being relatively mission critical. And the thing is that it's not like I think part of it, what you're paying for there isn't necessarily the software, but more of you're paying for all the support tickets and the iterations and the human support and like the person you can call when this thing goes down. And um, I think there's some of those primitives, those base layer primitives. I think those are actually going to still be valuable, and people are still going to pay a premium for that. So I think, yeah, I think it's a bit of a changing shape of like the parts that are valuable. But totally agree with you. Like, I think most just like workflow tooling is going to be uh, uh, replaced with home built stuff.
And I think like the real secret to the success of, pure software companies like CRM and tools like that is having that simple data visualization in front of them, that low code, no code tool that
Mhm.
they don't need to hire software engineers for anymore. But now, you know, anyone on their team can go in and, you know, automate a little task, things like that. And it's kind of what you've done, or part of the awesomeness of Sift is you've been able to take all these complex sensory data points, just put them visually in a nice, pleasing area where people can look at them. But I don't think that dashboards are the future. And I want to get your take on that. What do you think is? Are dashboards the future? Is just having that simple thing you look at how we're going to be, and you just not really going to see too many software engineers anymore?
Yeah, well, okay. So the first part you mentioned are dashboards the
Sorry, that
future.
was long.
Yeah, no, it makes sense. But yeah, it's actually funny you say that because ever since we started the company, I've been saying the best dashboard is no dashboard. So
Mhm.
how do you move away from people looking at things? Because if you have humans looking at a dashboard, that means that you have humans in the loop, which means you're inherently not automated. So how do you actually move away from that world? And that's actually kind of the difference between this concept of monitoring something versus observability. So really the what I'm trying to move our customers towards is how do you put this automated instrumentation that's going to look at the data for you. So, and it'll alert you to something being wrong. So when something goes wrong, you can go root cause the hardware and go look at the hardware. But the whole issue right now that we have is all this stuff. Um, you need software engineers to go put this stuff into dashboards. Hardware engineers have to go to a software team to go figure out what's happening, go root cause the issue, go find the data from different places, put into a visualization for them. Whereas our whole idea is how do you actually get that software engineer out of the loop and then make it so the hardware engineer has access to data themselves. And today, that's with the dashboards. Tomorrow, that's going to be giving them direct access to, um, uh, they only look at the data when something went wrong. So they only, instead of monitoring like a rocket launch, it's only when some sensor fails, they go look in and they say, okay, the sensor failed. Let's go figure out what broke.
Okay. Yeah, the monitoring the situation without human input, or humans in the loop, of just being able to understand when something isn't working right, rather than going in and try to
Watching it.
constantly watch everything.
Yeah. Think about it. Starlink has what, 10,000 satellites today? They don't have 10,000 people sitting in a warehouse staring at some dashboards.
Very true. Yeah, no, I like your take on this. Curious, what's something else you're really excited for that maybe a lot of people aren't paying attention to right now? Sorry, it's a bit of a pivot, but
Yeah. Well, because when I say that a lot of people aren't paying attention to, I think your audience might be paying a lot of attention to, but the general public is not. So I think what I mean by that is where I think it's interesting because the first few years of the company, all the investors would always be asking, oh, what about vertical expansion? What customers are doing outside of aerospace? And they're always curious about, oh, aerospace might be a fine incubation area, but like, what about the rest of the market? And it's interesting because I don't know if people feel that way anymore. And I actually am a lot more bullish on space and the moon. I think people aren't thinking about the moon or like the scale of the moon or how soon that's going to happen. I think that's an area that people are not paying enough attention to. Um, in the sense that when I said it's like the ultimate high ground, it's literally like it's like a forward operating base that overlooks the entire Earth. So not only from like a manufacturing aspect, but even from a military aspect, like the moon is one of the most one of the most important resources to make sure that we have um, access to. And on top of that, you have everything you need for manufacturing. It's like basically a massive open air mine to go build whatever you need for space, whether it's silicon, iron, etc. And I think if you actually want to start thinking about, if you want to bring this like software perspective of like scale to the physical world, the moon is like the most scalable place to do a lot of this stuff. So, in terms of, let's say, energy, in terms of manufacturing, solar, in terms of doing things that would cause friction on Earth, whether it's like nuclear or nuclear things, stuff like that. So, I think a lot, I would say the moon is something that should be changing from a science experiment um to like a proper
Infrastructure.
manufacturing hub. Yeah, proper infrastructure for like infrastructure of the solar system. Because
Yeah,
I also don't think the moon is a destination. I think it's a very much, as I said, like a forward operating base for the rest of the solar system.
and we're gonna have all sorts of new problems and ways to do things in this lunar economy, this lunar infrastructure. And they're going to have to maybe not figure out things so much as they go. Well, definitely figure
Yeah.
out things as they go, but they're going to have to do a lot of things new, brand new for the first time that they haven't done because it's just not
Yeah.
terrestrial anymore. And is Sift's going to be
Well,
able to help that and really be the guardian of just saying, here's what's working, here's what's not.
yeah. I mean, definitely. I think we have a weird, I could say oddly that a majority of the vehicles that go to the moon or plan to go to the moon are currently running on Sift. So I think
Nice.
we have a nice odd niche there. But I think actually, if you wanted one thing your audience might not be thinking about that I think is also going to happen is a lot of the stuff in the healthcare space right now. Like, let's talk about, there's a lot more gene editing going on. And gene editing right now, you talk more about how do you get rid of harmful traits, but that doesn't necessarily mean that you can't just add new traits. Like, can we add traits for people to be more radiation resistant? Can you add traits to people that they can survive, like their bone density can survive and operate with different amounts of gravity and are optimized for different amounts of gravity. And I think that's something that's a little bit out there that I wouldn't be surprised in like the next 10 to 20 years if we start actually getting more people that they're actually like they're like Martians, like true like human for like started with as humans, but they're like biologically born as like Martians.
I like that. Very interesting. Wow. Okay. Well, Karthik, this has been a fantastic conversation. For anyone listening to us, if they were to, walk away with one big takeaway about the things we've discussed, what would you want that to be?
That space is coming a lot faster than they realize.
I like that. Okay. Well, Karthik, it's been absolutely terrific to have you on. Thank you so much for taking the time to join us today.
Awesome. Thanks, Aidan. See you.
All right. Take care.